Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Differential Equations. Subtopic Formation of Differential Equation whose general solution is given. Exercise 9.3. Formation of a differential equation whose general solution is given. Form a differential equation that will represent a given family of curves. Given family of curves piramlaga differential equation semba. If the given family f1 of the curves depends on only one parameter, apiba family of curves two parameter amakhaktada depend taurabadi, then it is represented by an equation of the form f1 of x y a equal to 0, equation 1. Adugumba equation of the form dudi equation 1 gi format asini. Differentiating equation 1 with respect to x, we get an equation involving y dash y x and a. Adugumba mathak equation 1 asi x na differentiate taurabadi equation amakak phangani y dash y x and a yauba. That is g of x y y dash a equal to 0, equation 2. The required differential equation by eliminating a from equation 1 and 2 is mathak equation 1 amasung 2 dagi arbitrary constant a simanghalaba matungda aikoina asugumba equation ama phangani, that is f of x y y dash equal to 0. Anisuba form a differential equation that will represent a given family of curves. Apiba family of curves piramlaga differential equation semba. Sidasu if the given family f2 of the curves depends on only two parameters. Adugumba apiba given family of curves two parameter ani khaktada depend taurabadi, then it is represented by an equation of the form f2 of x y a b equal to 0, equation 1. Adugumba x parameter ani yauba curve singi family equation adu f2 asina mahut singane. Differentiating equation 1 with respect to x, we get an equation involving y dash y x a b. Mathak equation 1 asi x na differentiate tauraga differentiate tauraga y dash y x a b yauba equation g haina kauba equation ama phangane madu equation 2 haina kaure. Again, differentiating equation 2 with respect to x, we get an equation involving y double dash y x a b. Hariba nusing si yauba equation ama phangane, that is ice na madu khangnare x y dash y double dash a b equal to 0, equation 3. The required differential equation by eliminating a and b from equation 1, equation 2 and equation 3 is mathaki equation ahum sidagi a b asimang halaba matungda aikoina equation ama phange maduna required differential equation dune equation ado asumna ibayai f of x y y dash y double dash equal to 0 ngasai arbitrary constant ani do hojikti udre amasi manghallaba matungda derivative sing dependent variable independent variable yaw equation ama phange basina required differential equation adone. Exercise 9.3. Question 1. Form a differential equation representing the given family of curves by eliminating arbitrary constants a and b. Ahanba equation ada a b haiba arbitrary constant ani yauba family of curves asidagi differential equation putu u haibani. Here x by a plus y by b equal to 1. Differentiating both sides with respect to x, we get for x by a we get 1 by a, and for this we have 1 by b into dy by dx, that is y dash. Integrate derivative of 1 with respect to x is 0. Equation ani phange amuka derivative lorabadi mathaki asi x na derivative lorabadi 1 by a di constant whose derivative is 0 plus 1 by b constant chongthokro y dash the x na loradi y double dash equal to 0. Eliminating multiplying both sides b, we get y double dash equal to 0, which does not contain a and b and also contains the derivatives, is the required differential equation. Question number 2. Form a differential equation representing the given family of curves by eliminating arbitrary constants A and B. Piriba curves family of curves asigi differential equation das mahaki differential equation to put to O haibane. Here y square equal to a times of b square minus x square. This involves only two arbitrary constants a and b. We have to differentiate it twice with respect to x. Y squared x loaded twice y is not x, therefore we have to multiply by dy by dx. That is y dash na puriro. Assume na sigi derivative x na loaded minus twice ax pange b squared constant is 0. 2 na divide to we get equation 1. Again, differentiating equation 1 with respect to x on both sides, we get applying product rule. Past function y remains unchanged. Y dash its derivative is y double dash plus y dash constant into derivative of y with respect to x is y dash. Y dash into y dash is y dash whole square equal to minus ax whose derivative with respect to x is minus a, which is equation 2. 1 into equation 1 as equation 2 the sinjalabadi we get with multiplying by x on both sides we get this masi phange. Question 3. Form a differential equation representing the given family of curves by eliminating arbitrary constants a and b. The function is y equal to a times of e to the power thrice x plus b times of e to the power minus twice a, which contains two arbitrary constants, that is a and b. We have to differentiate the given function twice. First, differentiating both sides with respect to x, we get y dash, whose derivative is thrice a e to the power thrice x, whose derivative is also minus 2 times of b e to the power minus twice x, which is equation 2. Again, differentiating equation 2 with respect to x, we get y double dash. For this 9a e to the power thrice x. For this we have plus 4b e to the power minus twice x, equation 3. Eliminating equation 2 multiplied by equation 2, adding equation 3, we get y double dash plus 2 times of y dash equal to 15a times of e to the power thrice x. And solving a times of e to the power thrice x, we get y double dash plus twice y dash by 15, which is equation 4. Equation 2 gives equation 2 the y dash is equal to 3 times of its equivalent value is this, and minus 2 times of b e to the power minus twice x. So we get, simplifying this, we get this, from which we have to solve b times of e to the power minus twice x is this, putting these two values, putting the values of a times of e to the power thrice x and b times of e to the power minus twice x in equation 1, we get y equal to this. For this sigi damakta di sigi damakta di siga mana khare aduga sigi damakta di siga mana khare silere hojik aikoina 13 na both side purirabadi we get again simplify toragadi 5 times of amuk 5 में divide to thokro y dash y double dash minus y dash minus 6y equal to 0. This is the required differential equation as it does not contain arbitrary constants a and b, which also it contains derivatives of dependent variable with respect to x. 4. Form a differential equation representing the given family of curves by eliminating arbitrary constants a and b. Apiba function asidagi arbitrary constant a ga b ga manghalaga differential equation putu u. Differentiating both sides with respect to x, we get 4y y dash, and apply product rule on right sides, we get first function remains unchanged into derivative of second factor is this, plus second function remains unchanged, derivative of e to the power twice x is 2 times of e to the power twice x. Putting standard values, we get twice y plus b times of e to the power twice x. Again, differentiating this equation, putting this equation in the simplest form, we get equation 1. Differentiating equation 1 with respect to x, for this we get y dash, for this we get minus twice y dash, for this we get 2 times of b times of e to the power twice x, which is equation 2. B eliminate, we have to eliminate b from 1 and 2. Dividing equation 1 by equation 2, we get left becomes this by this and right becomes 1 by 2. cross multiply and transfer, we get this, which is the required differential equation. 5. Form a differential equation representing the given family of curves by eliminating arbitrary constants a and b. Y equal to e to the power x times of a cos x plus b sin x. Here, this is equation 1. Differentiating both sides with respect to x, we get left becomes y ds. We have to apply product rule on the right side. First function remains unchanged. Derivative of second function is this, plus second function remains unchanged into derivative of first function is this. Taking out, and this factor becomes, which is exactly equal to y. This is replaced by y using equation 1. Transfer y in the left side, we get y dash minus y equal to this, which is equation 2. Differentiating equation 2 on both sides with respect to x, we get for this y double dash, for this y dash, and apply product rule on right side. First function remains unchanged. Derivative of second factor is this, plus second factor remains unchanged into derivative of first function, that is e to the power x. Its derivative is e to the power x itself. Replacing, taking out minus, we get the remaining expression is equal to this. Using 1, we get this. And for this from equation 2, for this from equation 2, we get y dash minus y, which does not transferring, we get this, which is the required differential equation. For question number 6, form the differential equation of the family of circles touching the y-axis at the origin. Y-axis pu origin the sokpa circle gi family singi equation adu differentiate from the putu. Let a be the radius of the circle, then a0 is the radius, is the center of the circle. In the circle adu gi radius oirabadi, then a0 is the center of the circle. Circle to the center to a0 or as in this picture, see circle is from the Sulabi, is from the Sulabi, in a positive or abadi, in a negative or abadi from the overside. Then the equation of the circle is x minus a whole square plus y square equal to a square, which is equation 1. Differentiating this equation with respect to x, we get for this, we get this, for this twice y and into y dash. For this its derivative is 0. Dividing on both sides by 2, we get this, and solving x minus a, we get y minus y dash, which is equation 2. Eliminating a from equation 1 and equation 2, we get x minus a the minus y dash to sindokro, y dash remains unchanged, a becomes is what, solving a from here, x plus y dash, and whose square is square. Eliminate expanding, we get this, and transferring, we get this, which is the required differential equation of the family of circles. For question number 7, form the differential equation of the family of parabolas having vertex at the origin and axis along positive y-axis. Vertex the origin oiba positive y-axis, axis along the positive y-axis ta axis oiba parabola gi family sing equation adu differentiate from the photo. The equation of all parabolas whose vertex at origin and axis along the positive y-axis is x square equal to 4ay. Here a is greater than 0. Differentiating this with respect to x, we get twice x for this 4ay dash. And dividing on both sides by 2, we get this. The differential equation of the family of parabolas is x square equal to a is replaced by x by twice y dash, and y remains unchanged. Simplifying, we get x times of y dash minus twice y equal to 0, which is the required differential equation of the family of parabolas. For I, form the differential equation of the family of ellipses having foci on y-axis centered at origin. Foci singna y-axis talaiba, center na origin oiba ellipse pumnamaki equation adu differentiate from the putu u. Let the equation of on ellipses whose foci on y-axis and centered at the origin is x by a square plus y square by b square equal to 1. Here a is less than b, equation 1 is in this picture. Differentiating both sides with respect to x, we get this, and dividing by 2 we get equation 2. Again differentiating equation 2 with respect to x we get, from this we have to solve this equation 2 dagi equation solve tore. Again differentiating this with respect to x we get this, and simplifying x y double dash plus x y dash whole square minus y dash equal to 0. This is the required differential equation of the family of ellipses having foci on y-axis and centered at origin. Question number 9. Form the differential equation of the family of parabolas having foci on x-axis and centered at origin. Foci na x-axis ta laiba, center na origin oiba hyperbola singi family gi equation adu differential form the putu u. The equation of hyperbola having foci on x-axis and centered at the origin is x square by a square minus y square by b square equal to 1. As in this picture, differentiating both sides with respect to x we get this, dividing by 2 and solving y dash by x equal to b square by a square. Differentiating this equation with respect to x, applying product rule on left sides, first function treated as y by x and y dash is treated as second function. First function remains unchanged, y dash its derivative is y double dash plus y dash remains unchanged, derivative of y by x is this, and for constant its derivative is 0. Multiplying both sides by x square we get this, which is the required differential equation of the hyperbola. For question number 10, form the differential equation of the family of circles having center on y-axis and radius 3 units. Radius na 3 units oiba family of center na y-axis ta laiba circle pumnamaki family da madu differential equation da putu. The equation of the family of circles having center on y-axis and radius 3 units is x minus 0 whole square plus y minus b whole square equal to 3 square. Expanding we get this. Differentiating both sides with respect to x we get this, dividing by 2 we get y minus b equal to this, and putting y minus b in the above equation we get this, and expand we get this, which is the equation of the family of circles having center on y-axis and radius 3 units. Question number 11. Which of the following differential equations has y equal to c1 times of e to the power x plus c2 times of e to the power minus x as the general solution? Y is here. Differentiating this with respect to x we get 4y dash. For this we get c1 e to the power x for this minus c2 times of e to the power minus x. Its derivative with respect to x is this y double dash. For this we get this, which is y. The correct answer is y dash is this equal to y, which is equal to option B. For number 12, which of the following differential equations has y equal to x as one of its particular solution? Y equal to x makara piriba differential equation singasigi particular solution oibage. Y equal to x whose derivative is y dash equal to 1, y double dash is 0. Putting y equal to x, y dash equal to 1 and y double dash equal to 0 in the three equation ahum sida sinjalasi. Only C is correct. C khaktang chungani, C ki value sing sida sinjama matamda chumi, C khaktang chum atai sing sida di lale. Answer A C. Thank you for watching video.